G'day. This is a brief introduction into microbes and their actions and nutrition and what they do, and then we'll get on to some my root tea experiments that I've done later on. So microbes, they want some conditions to live in, like on the top left, it's your carbon, and then you've got your nutrients that is right for them to survive, and then you've got your electron donors and acceptors. Then on the right, it's got to be the right conditions, so they've got to have the right temperature and pH and all that other stuff down there. But you really, if you're going to make your own, you want to make your own out of the right things. So here's the NPK ratios of some stuff that you can find around, but you've got to remember they've got some shit in them. So if they've got pathogens and stuff like that, you've got to boil it up, you've got to brew it with air to get rid of all the anaerobes for at least 10 hours. And then it's, you're starting to produce better stuff. And the stuff you want is things like this, the microbe insecticides like Bacillus thuringiensis, or other ones like azos, which I use, or some solubilizing bacteria, which are great for unlocking things, because their plants need things to be unlocked for them. And this is the catagens, which is the amount of antioxidants that's come out from the feeds, and you can see on the right hand side from -51, that's NPK. Now underneath, the pluses are from organics, vermiculins, so it's organic. And you can also use it for hydroponics. So here there's some NPK ratios of the vermiwash and vermicompost that they use for it, and for filtered tea newts. So just add your airstone and stop paying the man. You probably get better results too. Hello. What's that? Alright, I won't hurt you. Knee off to the side. Alright, I'll take this out and show you what I do with the roots, how to make a good root tea. Because there's so much beneficials that are in here that they should be reused. I put this soil temperature on cumulative microbial respiration, which is the organic CO2 that they put back into the atmosphere from their existence in the soil or from your substrate. And on the left, so there's soil temperature down the bottom, and the black bit is the carbon dioxide, the carbon. So 20 to 25 is optimum. I like mine at about 24, my soil probe. On the bottom, this is, I had quite a lot of fungus gnats there a while ago, and I was trying to still establish a good food soil web. And I also added a lot of nematodes, the Steen or Neem or Faltai, the ones that eat them, eat the larvae and the eggs. So while they were getting established, I stopped them getting in from the bottom, little pricks. So yeah, this is like a bit of a nutrient film technique that I did. It worked. So I'll culture that up too, they can go in the bucket. So I'm just breaking these root ball up. Trying to work it slowly, just to get the big piles of dirt that's stuck inside of here, not dirt, soil, sorry. Bacteria spores remain by number 2 when they go through budding fission, and number 3 they produce their prokaryotic cell, and in the back half of it they got their pre-spore, and up to number 6 they form the endospore, and then when it dies it's ready to be sprouted in favourable conditions. It's all pretty dry, which is good. That's a nutrient film technique, bit of cloth that I put in the smaller pot to stop the fungus gnats as well. So I just transferred it here, and if you look in closer there'll be shitloads of just weaved in and out of that. But yeah, that's pretty good now. It's very light. You can see virtually nothing's fallen out. But as I shake a shitload, yeah, that's pretty good. So it's going in now. Yes, it's the smallest motor in the world, and it's living too. It's in us as well. And see on the left hand side, it's in cells. So see the cell there? It's inside the cell walls actually, in the bilipid layer. So it's so damn tiny. We'll zoom in a bit. So down the bottom there, you've got the rotor and the stator, and it actually does spin. So the hydrogen plus, the protons, they come in and mix with hydrogenase and ADP to form the ATP, the adenine triphosphate. This mostly happens in the mitochondria. On the right hand side is an electron scanning microscope picture that's all coloured in, looking all spiffy. I need 3 litres next. So I put another 2 litres on it, so it's got 4 now. So this would be 6. And look at it, it's just covered. Not happy. Okay. Just covered actually. Look at that. So 6. So now I'm going to put the bubbler into it, and if I scoop the roots into this, there should be about 500 million, give or take a couple, 500 million bacteria in there. This shows microbes have a large biodiversity when it comes to soil. In micro-rich soil, you can have up to 10 billion cells ranging from different things. And once I finish culturing it up, so I'll put the bubbler in here, 2 air stones for 48 hours, and the water will be very, very dark, and it should probably culture 4 or 5 times. So that if I put a teaspoon here, it'd be like 2 billion, something like that in there. So if the way I test it is with this. So after I mix it round, it should already be pretty high just from that. It'll already be quite a few hundred. So I'll put it in, I'll block it off. Beep. You can zoom in on that. So what's that, 242 just from that little tiny bit then. (242 parts per million). So after it's been bubbling up for a while, I'd expect it to go 4 or 5 times. So it should be around 1,000 to 1,200 parts per million. This is the results from my compost tea and my root tea that I did with microbes. So on the left here, you can see the different growth phases that it goes through. So it's lag phase, then log phase, stationary, then death phase. And that all depends on the amount of oxygen and the amount of electron acceptors and donors that it has. And this is the bar graphs. So the top's all the compost tea, but we're not talking about that. It's the root tea down the bottom with the thick line. So it starts pretty sharply at the start, and then it goes up, and then it's stationary for a fair bit, and then it must get another kick at the end. So instead of going into a death phase, it goes upwards very nicely. Wow, it smells so nice and earthy, so rich. $1,000. Zoom in, please. This says increase microbial biomass because microbes hold nutrients. The higher the microbial biomass, the better. Measuring them is indicative information. So to measure them, you'd use a hemocytometer, which is usually meant for blood. It's got grid lines in it, and it's not cheap though. $700 US for this one, but I got a cheap one out of China. It's just the grid pattern wasn't as labelled. It still works fine. So you just got to add them up, you count in the middle, and then do the maths, and there's a serial number that you multiply it by to work out how much microbes are in your area. Thank you. Happy breeding, happy growing to you. Bye.